Welcome to learn everything we can possibly learn from Apple's VisionOS documentation, Part 7. Here, we'll be taking a look at the sample code Diorama, where we'll learn to design scenes for your VisionOS app using Reality Composer Pro. This goes into details that we haven't gone into in Swift Splash. First, you download the sample code, and next, we're gonna go and read the overview. Use Reality Composer Pro to compose and edit and preview Reality Kit content for your VisionOS app. In your Reality Composer Pro project, you can create one or more scenes, each of which contains a hierarchy of virtual objects called entities that your app can efficiently load and display. In addition to helping you compose entity hierarchies, Reality Composer Pro also gives you the ability to add and configure components, even custom components that you have written to the entities in your scenes. Here's the app. You can also design the visual appearance of entities using shader graphs, a node-based visual tool for creating reality kit materials. Shader graph gives you a tremendous amount of control over surface details and shape of your entities. You can even create animated materials and dynamic materials that change based on the state of your app or your user inputs. Diorama demonstrates many Reality Kit and Reality Composer Pro features. It displays an interactive virtual topographical trail map, much like the real-world dioramas you find at trailheads and ranger stations in national parks. This virtual map has points of interest you can tap to bring up more detailed information. You can also smoothly transition between two trail maps, Yosemite and Catalina Island. Let's go into the app and check it out. Here we have the app opened up. Let's take a look at this diorama, show diorama, and we have our very beautiful application here. Here we have Yosemite. Let's do a morph. Here we have half Yosemite, half Catalina. Once we do a full morph, we see Catalina here, as we saw in the demonstration earlier. Let's see what the scale does. Scale enlarges our model entity and shrinks it. Very cool. Alright, with that, I think we can begin to take a look at the next steps in the documentation for the diorama. Let's take a look at import assets for building the scene. Your Reality Composer Pro project must contain assets, which you use to compose scenes for your app. Diorama's project has several assets, including 3D models like the diorama table, trail maps, some birds and clouds that fly over the map, and a number of sounds and images. Reality Composer Pro provides a library of 3D models you can use. Access the library by clicking the Add button on the right side of the toolbar. Select the objects from the library, import them into your project. All right, let's take that first step and make sure that happens. So first of all, we're going to go to our Xcode. Let's go to a Reality Kit content package. Let's open it up. Here's our package. Let's open that up in Reality Composer Pro. And now, let's take a look at that button here. This is the Show Content Library button. And here are the things that we can bring into our Reality Kit. These are Reality Kit objects that we can bring into our Reality Composer Pro. Here's the Nerf and a Flint Igniter. We have so many items already that we can use. It's crazy. All right, let's take a look at the next steps. Diorama uses custom assets instead of the available library assets. To use custom assets in your Reality Composer Pro scene, import them into your project in one of three ways: by dragging them to the Reality Composer Pro project browser, using the file import from the file menu, or copy the assets into the .rk assets bundle in your project Swift package. Let's go over those three steps. The first is we're going to go to File, and we're going to go down to Import. And we can import those items. Next is copy the assets into the bundle itself. So that means we're going to go into our Finder, and that means that we go into our packages and reality kits and sources, content, and we throw them in here. Next, we just drag them into a Reality Composer Pro and drag them into this particular area here. I think that is probably the best option, the easiest option. Next, although you can load USDZ files and other assets directly in VisionOS, RealityKit compiles assets in your Reality Composer Pro project into a binary format that loads considerably faster than loading from individual files. Okay, that's nice. Okay, let's create scenes containing the app entities. A single Reality Composer project can have multiple scenes. A scene is an entity hierarchy stored in the project as a USDA file that you can load and display a reality view. In a reality view, you can use Reality Composer scenes to build an entire Reality Kit scene, or you store reusable entity hierarchies that you can use as building blocks for composing scenes at runtime. The approach Diorama uses. You can add as many different scenes to your project as you need by selecting File, New, Scene, or Add N. The Command N, sorry. At the top of Reality Composer Pro window, there is a separate tab for every scene that's currently opened. To open a scene, double-click the scene.usda file in the project browser. To edit a scene, select the tab and make changes using the hierarchy view, the 3D view, and the inspector. Here we have the scene called Diorama Assembled open, and this is the separate tabs of separate scenes that we have opened. Here we have Cloud A, B, and C, and Bird with audio. We're going to take a look at, this is the hierarchy viewer, this is the 3D viewer, and this is the inspector where we're going to make changes. Let's go take a look at that. Here we have our Reality Composer Pro. Let's take a look at Diorama Assembled. Here it is. We opened it up. It looks like there's a lot to see here. Let's see exactly what asset they have opened up. They have Kalina Rocks opened up. So a Cathedral Rocks. That way it's not as overwhelming. I definitely selected that. Perfect. Now here is the 3D viewer, and here is the inspector. Okay, next. Add assets to your scene. RealityKit can only include entities in a scene, but it can't use every type of assets that Reality Composer Pro supports as an entity. Reality Composer Pro automatically turns some assets like 3D models into an entity when you place them in a scene. It uses other assets indirectly. It uses image files, for example, primarily to define the surface detail of a model entity. Diorama uses multiple scenes to group assets together, and then at runtime, combine those scenes into a single immersive experience. For example, the diorama table has its own scene that includes the table, the map surface, and the trail lines. There are separate scenes for the birds that flock over the table and for the clouds that float above it. To add entities to a scene, drag assets from the project browser to the scene hierarchy view or 3D view. If the asset you drag is a type that can be represented as an entity, Reality Composer Pro adds it to your scene. You can select any asset in the scene hierarchy or 3D view and change its location, rotation, and scale using the inspector on the right side of the window or the manipulator in the 3D view. Let's go take a look at that. Let's drop in another bird. And here we go. There is another bird there. I believe it's pretty tiny. Here's bird with audio. Let's take a look at how many birds with audio we have there. Birds. Let's see how many birds we have in the birds. We have 5 birds, and this is our 6th bird. So we just drop it into our birds file here, and we have additional bird now. This bird is somewhere over here for some reason. And can we zoom in? Where is it? I can't identify it. We can identify this bird, that bird, this other bird, and this bird number 1, but this one is on the floor. So, deep inside our diorama, let's move it to where all the other birds are. Let's see that position. So we're currently at negative 6 cm in terms of the x-axis. That's where bird number 5 is. Let's do that and move that to negative 7 maybe. Next is the y-axis. The y-axis is to 114. Let's do 115. And the most important one, so now it's the x was this way, brought it to left, and y was up this way, and z is going to be how deep it is. So currently it's negative 13 deep, and we have negative 127. Let's see what that difference is. That is really far away, negative 13. So let's give it a negative 15. And we have added an additional bird. Let's rotate it a little bit because it's kind of flying it's kind of iffy the way it's flying. It's also really close to other bird. I think it's fine. It's just, let's move it a little bit to the x coordinate, maybe to a negative 15. Yes, there we go. Now it's a little bit further away. Perfect. And that's how you add another entity into RealityKit scene. All right, add components to entities. Add components to entities. RealityKit follows a design pattern called Entity Component System, ECS. In an ECS app, you store additional data on an entity using components and can implement entity behaviors by writing systems that use the data from those components. You can add components to entities in Reality Composer Pro, including both shipped components like physics body component and custom components that you write and place in the source folder of your Reality Composer Pro Swift package. You can even create new components in Reality Composer Pro, then edit them in Xcode. For example, for more information about ECS, see Use Understanding RealityKit Modular Architecture. And yes, this module is from the next bit in our documentation. Understanding RealityKit Modular Architecture. We'll be understanding more about ECS in a little bit. Diorama uses custom components to identify which transforms are points of interest, to mark birds so the app can make sure they flock together, and to control the opacity of entities that are specific to just one of the two maps. To add a component to an entity, select the entity in the hierarchy view or 3D view. At the bottom right of the inspector window, click Add Component button. A list of available components appear, and the first item in the list is New Component. This item creates a new component class and optionally a new system class and adds the component to the selected entity. If you look at the list of components, you'll see points of interest component that Diorama uses to indicate which transforms are points of interest. If the selected entity doesn't already contain a point of interest component, selecting that adds it to the selected entity. Each component can only have one component of a specific type. you can edit the value of the existing component in the inspector, which changes what shows up when you tap on the point of interest in the map. Let's take a look at some of these points of interest. So points. Oh, all right. Well, I don't see any points of interest at this point. And oh, maybe two persons landing. That's a point of interest. Let's take a look at that component. Oh, it has a point of interest component. Take a look at that in the inspector. And before we get ahead of ourselves, let's find out how to add a component. As you can see in the inspector, there's an add a component button right here. You click that and you can add points of interest component. As you can see, we've added that already. And so we cannot add a second one. So this is called persons. Sorry about that. So this is person's points of interest components, where we see that it has a name. It doesn't have a description at this point, but it has a sort of a tree rock type of main image, a secondary image, and third image. It's just a point in the map at this particular point position. All right, with that, let's keep moving. Use transforms to mark locations. In Reality Composer Pro, a transform is an empty entity that marks a point in space. A transform contains a location, rotation, and scale, and its child entity inherits those. But transforms have no visual representation and do nothing by themselves. Use transforms to mark locations in your scene and organize your entity hierarchy. For example, you might make several entities that need to move together into a child entity of the same transformation, so you can move them together by moving the parent transform. Diorama uses the transforms with a point of interest component to indicate points of interest on the map. When the app runs, those transforms mark the location of the floating placards with the name of the location. Tap on the placards to expands it to show more details and information. To turn transforms into an interactive view, the app looks for a specific component on transforms called a point of interest component. Because a transform contains no data other than location, orientation, and scale, it uses this component to hold the data the app needs to display on the placards. If you open the Diorama assembled scene in Reality Composer Pro and click on transform called Cathedral Rock, you'll see the point of interest component in the inspector. All right, Cathedral Rock. It's another transform, and it has a point of interest component as for the region Yosemite. It has some description about it, has no image. Very good. All right. Okay, let's load a scene at runtime. To load a Reality Composer Pro scene, use this link here and passing the name of the scene you want to load and the project bundle. Reality Composer Pro Swift package defines a constant that provides ready access to its bundle. The constant is the name of the Reality Composer Pro project with bundle appended to the end. In this case, the project is called Reality Kit Content, so the constant is called Reality Kit Content Bundle. Here's how Diorama loads the map table into Reality View Initializer. Let entity equals try-await entity dot load name diorama assembled in the Reality Kit content bundle. The function is asynchronously when called from an asynchronous context because the content closure of the Reality View Initializer is asynchronous. It automatically uses the async version to load the scene. Note that when using it asynchronously, you must call it using the await keyword. All right, let's check it out. Let's go find that piece of code. Diorama assembled. Here's the piece of code we're looking for in the diorama view. we have our reality view, and we're going to load the entity from our reality kit content and reality kit content bundle, which we named our package reality kit content. That's why we're going to add bundle to the end of it. And that's it. Wonderful. With that, let's move on. Create the floating view. Diorama adds a point of interest component to a transform to display the details about interesting places. Every point of interest name appears in a view that floats above its location on the map. When you tap the floating view, it expands to show detailed information, which the app pulls from the point of interest component. The app shows these details by creating a Swift UI view for each point of interest and querying for all entities that have a point of interest component using this query declared in immersive view.swift. Here we have a static let marker query, and we query everything that has a point of interest component. In the reality view initializer, Diorama queries to retrieve the points of interest entities and pass them to a function called create learn more view for, which creates the view and saves it for display when it's tapped. Subscriptions.append, content subscribe, component events did add, points of interest, components, events, create learn more views. All right, let's take a look at this piece of code and go into the details a little bit deeper than what's seen here. Oh, right. I believe it's this piece of code here. So this queries for all the point of interest components. And here we have created our diorama assembled. From this bundle, this is our entity, right? And our view model, root entity, content.add, our entity, and we update the scale. Very good. We particularly put the position, and we set up some birds, and we have a subscription.append. And this adds these items into our entity, which is called diorama assembled. And what we're adding in here are these components, these positions, and we're looking to create a create learn more view with each entity. And we can go into this function and we look at these components. If it has this component, get the entity point of interest component, which is in the Reality Composer Pro. All right. Highlight the trail entity associated with location. First has material parameter and adds a tag object identifier, gets the ID, creates a view, a learn more view with the name, description, image, and a view model. I do not know exactly for sure why it's a view model, but we can go into this view and learn more about it. So here's the view model. I believe the view model is the diorama assembled, and we're gonna update the region specific opacity here. I think that's about it. We're gonna take a look at the preview, and in this preview, we create a little bit of a image, and we should be able to see a nice little view here. Just give that a moment. And I think we just add everything into this body with a V-stack, Z-stack centered and everything, into a little frame of 408. Oh, okay, it looks like it crashed. All right, no problem. Oh, we did not crash. Never mind. We have our Phoenix lick here. Wonderful. We can take a look at that inside our diorama app. So here's the diorama. Here's a review if you go up and you click it, and it has more information. Same with Mercy and El Capitan. Very cool. Great. Let's take a look at the next bit. Create attachments for points of interest. Diorama displays the information added to points of interest components in a Learn More view, which it stores as an attachment. Attachments are SwiftUI views that are also RealityKit entities, and that you can place in a RealityKit scene at specific locations. Diorama uses attachments to position the views that float above each point of interest. The app first checks to see if the entity has a component called Point of Interest Runtime Component. If it doesn't, it will create a new one and add it to an entity. This new component contains a value that you can only use at runtime that you do not need to edit in Reality Composer Pro. By putting this value into a separate component and adding it to the entity at runtime, Reality Composer Pro never displays it in the inspector. The point of interest runtime component stores an identity called an attachment tag, which uniquely identifies an attachment so the app can retrieve and display it at appropriate times. All right. Next, the diorama creates a SwiftUI view called a Learn More view with the information of the point of interest component, tags the view, and stores the tag in the point of interest runtime component. Finally, it stores the view in an attachment provider, which is a custom class that maintains reference to the attachment view so they don't get deallocated when they're not in the scene. Here's the object identifier, here's learn more, here's the point of interest, here's the view model, here's the tag right here, and here's the entity.component, point of interest, runtime component, and we're going to do attachment.tag with an attachment tag, this particular tag. And that's how we create an attachment so that it doesn't disappear when it's not, so it doesn't get deallocated when they're not in the scene. Display points of interest attachments. Assigning a view to an attachment provider doesn't actually display the view in the scene. The initializer for Reality View has an optional view builder called Attachments that's used to specify an attachment. For each attachment provider, .sorted tag view peers at the ID tag pair.peer.view. In the update closure of this the initializer, which RealityKit calls when the content of the view changes, the app queries for entities with a point of interest runtime component, uses the tag from the component to retrieve the correct attachments for it, then adds the attachment and places it above the location in the map. So view model root.entity perform query. Okay, we have all the runtime queries, and for each entity, Gartlet attachment entity, attachment.entity, for component.attachment tag, and if let point of interest component equal entity.component, we'll do a attachment.entity.component.set the particular region and the opacity. Then we're going to add this view model.root entity, add the child of this attachment entity, and set the position from with a y of 0.2 away relative to entity. All right, let's take a look at that in the code. Here we have that first statement where we attach every single tag that we find into our diorama. This is the same piece of code that we can see here. Next, we take a look at this piece of code. It's a little different now, but I think it's the same piece of code. As you can see here, we perform the query, one-time query, and we get the components, and we have the attachment entities. And we do a we get the entity of the collections key of attachments keyed by tags, and we attached attachments are region specific, and they react when slider changes from one map to another. Take the region configuration in Reality Composer Pro and give it the corresponding attachment entities. These entities also need opacity components so they can fade in and out with the as the map changes. So here's the components, point of interest components, and we put these components in, and we set them at 0 opacity. Here we add these entities as childs of the entity, and we have a we raise it from the view so they're not too sunken into the terrain, so by a 0.4. All right. This is 0.2 here, but I think it's just maybe it's slightly configured code. Okay, let's create custom materials with shader graphs. To switch between the two different topographical maps, Diorama shows a slider that morphs the map between the two locations. To accomplish this, and to draw elevation lines on the map, the flat terrain entity in the diorama assembled scenes uses a shader graph material. The shader graph is a node-based material editor that's built into Reality Composer Pro. Shader graph gives you the ability to create dynamic materials that you can change at runtime. Prior to Reality Composer Pro, the only way to implement a dynamic material like this was to create a custom material and write metal shaders to implement the necessary logic. Diorama's dynamic terrain material enhanced does two things. It draws contour lines on the map based on the height data stored in the displacement map image, and it also offsets the vertices of the flat disks based on the same data. By interpolating between two different height maps, the app achieves a smooth transition between the two different sets of height data. When you build shader graph material, you can give them input parameters called promoted inputs that you set from Swift code. This allows you to implement logic that previously required writing a metal shader. The materials you build in the editor can affect both the look of an entity using the custom surface output node, which equates to writing metal code in a fragment shader, or position of vertices using the geometry modifier output, which equates to metal code running in a vertex shader. Node graph can contain subgraphs, which are similar to functions. They contain reusable sets of nodes with inputs and outputs. Subgraphs contain the logic to draw the contour lines and the logic to offset the vertices. Double-click a subgraph to edit it. For more information about building materials using shader graph, see Explore Materials in Reality Composer Pro. I think we don't do that, but that's one thing we can do in the future. Okay, so I've pulled up the dynamic terrain material enhanced in the hierarchy view here, and we see angle compensation, we see lines, um, we see secondary lines, and we see test progress drivers. Here we have a little demonstration of the lines in the cube, in a sphere, in a plane, and that's how we see our materials. Here's outdoors, indoors, and the studio. That's very cool. And this is our shader graph down here, and we don't know much more than that at this point. And all these vectors and ideas uh, are going over our heads. So what we need to do is look into Explore Materials in Reality Composer Pro a little later, when we do need to enhance our materials. Let's look into that later. Next, we're going to update the shader graph material at runtime. To change the map, Dynamic Terrain in Material Enhance has a promoted input called progress. If the parameter is set to 1, it displays Catalina Island. If it is set to 0, it displays Yosemite. Any other number shows a state in transition between the two. When someone manipulates the slider, the app updates the input parameter based on the slider value. Important. Shader graph material parameters are case sensitive. If the capitalization is wrong, your code won't actually update the material. The app sets the value of the input parameters in the function called handle materials that the slider onChange closure calls. The function retrieves the shader graph material from the terrain entities and calls set parameters on it. Here's our handle material code, and let's take a look at that inside our Xcode. Handle material. Oh, what's going on? We were looking for the handle material function. All right. Well, let me take a look at that. That's interesting. Let's look for that guardlet terrain maybe then. Let's see what's called now. It's update terrain material instead of handle material. So they changed the function name. That's why we couldn't find it earlier. And so we have the guardlet, the terrain material, and we do have a set parameter, and we have a value dot float based on the slider value. And based on that slider value, we do we set the components, update the shader graph material using the terrain material based on the slider value, and otherwise we have a problem. All right, that is very cool. Um, that's very insightful. And with that, we have gone over the documentation for Diorama. In this tutorial of this documentation, we learned about updating the shader graph material at runtime. We have created custom materials with the shader graph. We haven't done it ourselves. We know what we're looking at, but we don't know how to do it at this point. We have display points of interest attachments. So this is how we can create points on a particular entity. We have to create attachments for the points of entity and create the floating view for all of that. Here's how we load a scene at runtime. We load the set diorama assembled using entity.load. Use transform to mark locations in Reality Composer Pro. Add components to entities using Reality Composer Pro, add an asset to our scene using Reality Composer Pro, and create scenes containing the app entity by using it at Command N and adding items together and building this entity together, this scene. Here are some assets that are generic and our custom assets. With that, we have gone a quick overview about Reality Composer Pro to how to compose, edit, and preview Reality Kit content for your VisionOS app. I really enjoyed this documentation here about Reality Composer Pro and a quick overview on how to attach Reality Composer Pro entities that we have created from multiple entities. We'll create a scene from multiple entities and pulling that scene into our Swift UI code and displaying it in our app. We are far from being able to do it because we haven't not gone into the details and have not done it ourselves. And there's much more to learn here. But I hope let's learn more in the next video about and from the more of documentation, and let's become VisionOS developers.